4 actually switches gears just slightly because now you are going to be writing the variables and the equations. So in this first example, they're going to give you a verbal sentence. They're actually going to do it in written words, and you have to figure out how to write that as an equation, or I guess we're working all with equations here. So the verbal sentence is the sum of x and 6 is 9. We're going to make sure we look for the operational word, which is sum, and sum means addition. So we had x, we combined it with 6, the sum of, and we end up with the is always the equal sign. Now we have the next one, difference. Be careful with difference because you need to make sure you have it in the correct order. So the difference of 12, so 12 is going to be my first number, and y. So I did 12 minus y, and then the is giving us the 15. The next one is the product of, and product means multiplication. The product of -4 and p. I'm always going to put my variable first, and remember, now that we are getting more into algebra, we do not have to, we will never ever write the multiplication symbol. We won't write this because that can be, we can misunderstand that and think that that's the variable x. So we will never ever do that. And we do not have to use the parentheses. We can just write them right next to each other. The same goes for, we don't need to use the multiplication dot or the parentheses. We can leave that out of there and just put a variable right next to the coefficient using our new vocabulary words. So product means that that's multiplied by the variable. So -4p is 32 or equals 32. And then our last one, sometimes you forget this one, quotient. Should be pretty easy in this case because we've used all our operations. Again, on subtraction and on division, be very careful how you write them. You want to write them in the correct order. So the quotient of n and 2, so that means when you're dividing that variable by 2, is 9. So that equals 9. So a little vocabulary review on operations for this one. Now we're going to check possible solutions. So tell whether 9 or 7 is a solution. They're going to give us the equation, and this is kind of a fancy when. We're going to substitute them in and see which one is the correct answer. So we have x minus 5 equals 2. Let's substitute 9 in. 9 minus 5 equals 2. No, 9 minus 5 equals 4. So you're going to see we've gone ahead and we've given the symbol of not equal to. Substituting the 7 in, we get 7 minus 5 equals 2. 2 equals 2, so that is a solution, or we can write the equal sign. So not a solution, we write the equal with the diagonal line. It's not equal. And equal, we just still write the equal sign. So let's go ahead and check if we understand what we were doing there. We have the sum of 3 and z. So I'm going to do 3 and z, and that's going to equal, oops, -10. See if I can sneak a negative in there. Whoops, thinks that I want to, that negative doesn't want to show up there. Oh, it went back on the, let's try here. Oh, there's my -10. We have the quotient, that means division, of m and 6, so m divided by 6 is the equal 4. And let's go ahead and try one of the tell-whethers, which is kind of a fancy when. -8, and we'll substitute in the -5 first. We want to see, is that equal to 40? Let's apply our integers. Integer rules, negative times a negative gives me a positive, so I end up with 40. And 40 is equal to 40. So this one is a solution. Or you can just leave it as an equal. I'm going to try the next one, -8, and this time I'm substituting in 5. Does that equal 40? A negative times a positive is going to give me a negative, and -40 does not equal 40. So So this is not, or you can just leave it as the equal sign with the diagonal. It is not true. So we're going to write and solve an equation for this next one. And we're going to talk about some go-karts. And so it says go-kart rides cost $5. And here's an operational word, each. Okay, if I'm going to do something each, that is multiplying at a county fair. During the first day of the fair, the go-kart operator takes in, that means they got a total of 1,000. That means the equals. So it equaled $1,000 at the end of the first day. How many times did the people ride the go-karts? So if it was $5 each, and let's go ahead and use the variable x. That's the most popular variable. So it was $5 for each, but we don't know how much the each is, so that's going to be my variable. 5x equals 1,000. Okay? I think I have this slightly different than the one in the book. So I'm going to go ahead and I'm going to continue the one that I copied down instead. So if 5x equals 1,000, to find out how much x equals, I have to do the opposite operation. So I'm going to divide by 5. And if I do that on one side, I'm going to do it on the other side. So this time x equals 200. There were 200 people that rode the go-karts that day. Oh, and that got us to 2.5, so I'll finish the 2.4 recording here.